I'm a bit perplexed. Can you go back to the interaction tadi? The interaction between the two. The interaction table.
This one?
Yeah, types versus staining. So you see, in the multiple comparison, there is a significance tau. Distilled water versus turmeric. Yalah. But in your multiple comparison, it's not significant. I wonder why. Is it because of the low sample? No, I don't think so. It should not happen. Because you see, the p-value is less than 0.001 for distilled water versus turmeric. But staining is definitely significant. But the interaction is not significant based on the multiple comparison. However, it's odd that the multiple comparison for yelah, staining lah. Betul. Sorry. Yeah, silly me. Yeah, it is a staining one. Yeah, correct, staining one. Betul.
Okay.
What am I saying? Sorry. Yeah. Betul lah, staining lah, memang lah. It's staining.
Yeah, okay.
Yeah, sorry, silly me. Okay, so the next one.
Good afternoon, Dr. Zafri.
Yes, good afternoon, Dr. Inas.
I'm Joel. How are you?
I'm good, thank you so much.
I don't want to interrupt you at the very beginning, but I lost the very beginning part of the...
Okay. Yeah, so in the beginning, we were looking at the normality. So based on the initial analysis, usually when we do the analysis, first of all, we look at the Kolmogorov-Smirnov or the Shapiro wheel. So if that does not fulfill the requirement, so we look at the degree of skewness and kurtosis. So looking at degree of skewness and kurtosis, there are two ways of doing it. One is via the mathematical method. So using the mathematical method, the statistical value, the statistics value of the skewness or kurtosis should fall between positive or negative of the standard, twice of the value of standard error. So minus 2SE should fall in between, the statistic value should fall in between minus 2SE and positive 2SE. That's the mathematical method of doing it. There's a secondary look of how we want to measure normality. So if skewness falls within that range, then we consider it normal. If it doesn't, then we have to move to kurtosis. So if kurtosis falls within that range as well, then we consider the data set is normal. So if, let's say, one or two data set is not normal, if you have multiple data sets, I mean you have 3 or 4 variables, we can use the rule of majority. So the rule of majority can take into consideration that more of the data is normally distributed, but there is a caveat to it. We have to take the probability that the end result of the parametric test may not be significant.
All right.
Yeah. So in this case, for the first, one, what was it just now? Why staining? The first one was what?
The staining.
The first one was okay. Both are considered normal. The second one of it wasn't normal, but we take the rule of majority that the other one is normal. So, but we put in the caveat that the probability of the parametric test that will be done will not be significant. And when Xin-Yi did the two-way ANOVA, it is only significant for the staining, but it doesn't work. Yeah, but it is not significant with the type, nor was it with the interaction. Yeah. So that's the probable indication that it may not be significant.
Okay, how about the sample size effect, Dr. Safir?
Come again?
The sample size.
Yes, of course, the sample size plays an effect. Of course, a larger sample size would be better, but that is on the basis that you have to actually, one of the things that he can do after this is to calculate the effect size. If the effect size is low, then probably for future studies you can increase the sample size to actually increase the results.
So how can you just briefly tell us how to do that, to calculate it?
The calculation, I think, Shingi, you have the book, yeah?
Yeah, I have the book.
Yeah, it is actually manually calculated from there, but I can't remember the exact formula for it. But it's a manual calculation that you can do with that is written inside the book for the effects.
Shouldn't be exceeded, then only we will know that.
No, it doesn't give you an exact this one. It doesn't give you an exact value. It will be just a conclusion that if you increase the sample size, but it doesn't tell you how much the sample size should be increased.
Alright.
Yeah. It is just more like a very how shall we say a manner of assumption that if the sample size is increased, then it will solve the problems. It will increase the likelihood of getting a better results, which is most of the time that is the case.
Yeah. But whether our sample size is not enough.
Well, if you want to really know that if it's not enough, then you have to calculate for the observed power as well. There is another calculation that needs to be manually calculated. That is also written inside the book. So if the observed power is sufficient, 0.8, then regardless your result is significant or not, the sample size that you have for your data is sufficient. For observed power and sample size is meant based on your existing data, which is in his data.
First hypothesis, as you can see, we're comparing two different types of ceramic.
Yeah.
That has been soaked in three different solutions, cleaning solutions.
Mm.
So in this hypothesis, we didn't include another variable, which is the ceramic thickness.
Okay.
Okay. So let's say if we wanted to check the effect on the state of the staining on the ceramic thickness as well, can we run one statistical analysis in one shot, or we need to do another test?
You can add it as a layered analysis, but I fear that the interpretation will be quite complex.
All right. Okay.
Yeah.
Okay.
You can do it separately if you want, but it can't be done as a single. Which is my only concern is the complexity of the interpretation. So it's a bit of a complex kind of analysis.
Okay, so if we want to do it separately, same test we're gonna use. It's just that
you have to replace one of the variables.
But here the types are two types only. However, if you want to do it like in different thicknesses, for every type there is two different thicknesses, so the total is 4.
Yeah. So if you want to add it as an additional analysis, whether you add it as a layer or you analyze it by type. Is it by type? I think by type, right?
That's
by type, yeah.
Type and thickness together. So for every type there is two different thicknesses.
Yes. So you have to analyze it within the type. So yeah. So because if you look at like a root structure, how do I say? Look horrible. I'm sorry. So you have the type itself, and each of the type has its own. So there is an additional layer to the analysis.
Yes.
Yeah. So either you, if you want to analyze it, you have to add the additional layer, or you analyze it by type.
Oh, okay.
Yeah. So it
So
will
we
be less.
have to select only the two different thicknesses, one test, and another test for the two different thicknesses of the other type.
Exactly. You can do that. The only caveat, the only drawback for that is that there is a probability of the interaction between those two types.
Yes, this is the
Yeah.
thing.
Yeah, that's the only concern. But I do not think that should be much of an issue. You can do that separately if you want.
Okay. Thank you. Can we go for the second hypothesis, Sini?
Doctor, can I ask a few questions more?
Yes,
Yes.
go ahead.
So regarding the normality test, do we usually have to add in the control or without it?
Control?
Because since we have 3 solutions, do we need to include the distilled water because that is a control in our normality test?
Oh, yeah, you're supposed to.
You have to add.
Yeah, you have to add. You're
Because
supposed to.
I did it in two times. One is without the control, and one is with the control.
Oh, you're supposed to do it with the control.
Oh, okay.
Yeah. But even so, I can see from here already the kurtosis is okay.
Okay.
Yeah.
Okay. And doctor, do we need to mention our normality test in our report?
Yes. Okay. So in your chapter 4 in your report, it doesn't have to be overly complicated. You can put the table as part of your appendix, and the normality you can mention it as a separate section in the results, talking about just normality, but briefly. You don't have to make it overly complicated. You know, at most, when you say you assess normality, what are the parameters you are looking at? For those that was not normal at Shapiro-Wilk level, you will look at the degree of skewness. When you look at the degree of skewness, which parameter are not normal? So further details on this normality can be seen clearly in table 1, for example, and this table 1 in the appendix lah. And then you highlight those which are normal and not normal from the table that you match in the appendix. So you can just keep it to at most a single or half a page for your normality for all of your tests.
Oh, okay. So doctor, usually why we use Shapiro?
Because Shapiro-Wilk, if your grouping is less than 30 for clinical studies, you use Shapiro-Wilk. If it's more than 30, use Kolmogorov-Smirnov. Oh, sorry, yours is more than 30. Is it?
For total is 72.
No. Per group. Per group is more than 30, right?
Yeah. 30,
Sorry.
30.
Then you use Kolmogorov-Smirnov. Sorry. But
But
usually,
it's almost,
yeah,
the
it's
value
not,
is almost the same.
yeah, it's almost the same. It's not that far different.
Okay.
But sometimes, especially when you have small samples, it will show a difference, especially when you use Kolmogorov-Smirnov and Shapiro-Wilk.
Then can I move on to the next hypothesis?
Yes, of course, please do.
Okay. So the hypothesis 2 is comparing two types of material and the thickness, compare before and after the thermocycling. So for this, I am also using two-way ANOVA. Okay. So this is a normality test for the type.
Okay, so normality.
I think it's quite okay.
Okay, that's good.
Okay. This is for the thickness.
Okay.
Only because since we get the Smirnoff, so it's okay also.
Yeah, it's okay also. Yeah.
Yeah. Okay, and this is the between subject.
So the Levin's test, it's less than 0.05, doesn't matter because the final result is already corrected by the ANOVA. So here we can see. So the corrected model is not significantly different. And when you see the intercept when you see the thickness type and the interception between the two, there is also no significant difference. So this means that there is no differences either in thickness or type.
Yes.
Okay.
Okay. I think for the below part also should be okay.
Yeah.
There is no post hoc because only two. Two.
Yeah. True. It's alright. Don't worry.
Dr. Ines, do you have any questions? I think that's all for me for this hypothesis.
Okay.
I think this one is quite clear.
Come again, Dr. Ines?
This result is quite clear.
Yeah, this is very clear. There's no significant difference because the p-value initially was already there. So there's no point in looking at if there is a post hoc. There's no point in looking at it. We usually stop at this level already. If there is significant difference, only then we'll dive in on the further analysis.
So here there is no significant difference, right?
Yeah, there's no significant difference. So there's no point in looking at the subsection of the analysis.
All right, but I want to ask you something about the interpretation of data. Can you go down a little bit more down? Okay, here. This one, the first table, showing the 0.5, the thickness is 0.5 and 0.7. I know that there is no significant difference there. But I can see like the 0.5, the value is a bit higher, the mean.
Which table?
This table.
Okay, this table. Okay, right.
But we still, in our discussion maybe, we still can use the mean as a descriptive statistic to show that 0.5 has been affected more, even though the effect wasn't that significant, right?
Yes, you can, because please bear in mind, there's something that that sometimes I do tend to forget to tell. What is statistically significant or non-significant is not necessarily statistically significant or non-significant in the clinical value. So sometimes when you have a difference in results in the statistics, even if it's not significant, it can mean something for the clinical aspect. So this is something you can discuss as well. But the differences is just 0.1, Dr. Ines. It's very small. The one for 0.7 is slightly bigger, 0.4.
Which one? The first table? Is it the first?
Because it's 3.9 versus 4.0 and 3.5 versus 3.1. The second one is slightly bigger.
Yeah, this is what I mean. I'm not talking about the type of ceramic here. I'm talking about the thickness. So between 0.5 and 0.7, there is quite some difference.
Yes, there is. And so as I said, clinical significance is a different thing. Statistical significance, in this manner is not significant. But there is a probable clinical significance in your case. So the amount of difference is for 0.7 is slightly higher than 0.5.
Okay.
Yeah, you can discuss this. There is even a probable. You can add even in discussion if you have even more data. The result could prove significant.
Okay. So actually, what I wanted you to help me is, because here we were checking the thickness, the ceramic type and thickness, and the effect of thermocycling on that.
Okay.
So from this table, I can see that let's say the 0.5 has been affected more than 7, even though there is no significant difference. I want to get something like this to summarize the staining effect on the thickness.
You have to repeat that. You were breaking up. I didn't hear you.
Sorry, yeah. I said I want something to help me to see or to summarize the effect of staining solutions on the thickness, on different thicknesses. So table like this, but it summarize the staining effect on different thicknesses. So I'm going back here to hypothesis number 1. So what do you suggest us now?
Okay, so for this is between type and staining, right?
Is it this one? This one is between
Thickness.
thickness and thermocycling.
The second is thickness and thermocycling. The first one was type and staining, right?
Yes.
Okay. So what you want to do now is to assess thickness and staining.
Yes.
So if you have the two variables for thickness and staining, I think you can analyze it as in a similar fashion, I believe.
Same like the hypothesis one, but change the type into thickness.
Yes. If you have the data for that, yes, why not? You can repeat the analysis specifically for thickness, and then and the staining as another variable. That's why I mentioned that within the groupings, you have the two types and two different thickness, correct?
Yeah, for this, yes.
Yes. So you can actually analyze the thickness within each type versus the staining. So your variables, instead of adding a layer, you analyze it by type, but the actual variables replace the type with the thickness instead. So you analyze for one type of material for each of the thickness versus the staining, and the other type, the two different thickness versus the staining.
Then we compare the type and the thickness later, is it?
No, you just compare the thickness for each type.
So then we won't be able to compare two different types, right? Only the thickness among each type separately.
Yes. If you want to add that, you have to add another layer for the analysis. So that would be quite complex. Yeah, that would be a bit complex. I have not done that third layer of analysis yet. Yeah. You can attempt these two first. If there is something there, then it's worth exploring for the other layer.
Oh, we do it separately first and we see how.
Yeah. If there is an exact difference between the thickness for this one, then it's worth looking for the other layer. Then I'll seek help from my senior statistician to help me on that. Because I've not done on a third layer basis. At most I've done on the second layer. So what Shin-Yi has done is a two layer analysis. I've not done on the third layer myself. I need assistance on that. Is that okay?
Okay for now.
Is there anything else you need? Or Dr. Inas?
It is quite clear now to me. Thank you. I don't know how about for me.
Same for me.
Okay. So if there's nothing else, so you try to do that one first, Shin-Yi. And then you can email me your results.
Okay.
If you tell me if the result is significant for the thickness for each of the two materials, then I'll ask help for the third layer. Is that all right?
Okay.
Okay, thank you very much. So if there's nothing else, so I guess we'll break for now. Before we go, Shin-Yi, can I have your metric number?